Okay, so chapter 6, section 3, we're solving multi-step inequalities. Solving, for the most part, two-step inequalities. You've done this before. It feels just like an equation, but rather than an equal sign, we have an inequality sign. So when solving, again, what is the two-word phrase that is a synonym for solving? To solve is to... begins with an I. It's isolate variable, if we don't include the word the. Isolate variable. That's what solving means. Isolate variable. Get it alone. So what would we could do anything we want to both sides of this inequality to maintain equality, but what would be probably the best first move?
Reverse PEMDAS.
Very good. Lindsay's saying it. Probably reverse PEMDAS. Most people have the most success here. So the first operation we will use to undo is, say it. Subtract 6. So when we subtract from the left side of the inequality, of course we have to subtract from the right side. The inequality sign is like a fence. What you do to one side, you must do to the other to maintain the same equivalent statement, right? Or an equivalent statement. Bring down the inequality sign first, so you don't forget. I did see in someone's assignment yesterday that they brought down equal signs every time. And I said that can happen. We're so used to working with equations that we just keep using equal signs. But these are inequalities, so don't forget to bring it down. On the left side we have 4x, and what do we have on the right side?
48.
Yeah, 48. And now, Casey, what do we do to undo this? Divide by 4 to undo the multiplication. And we end up with? 12. There you go. And it does ask us to graph. So we want to see 12 on our graph. And be sure to show one or two other numbers so I know your scale. So each line here is 1 unit. Okay? And so Casey, what kind of a dot?
It's solid.
Solid because we have greater than or equal to, right? So, and it goes to the right. Okay, so let's just test a point. Let's test 14. 14 is on this ray. So is 14 greater than or equal to 12?
Mm-hmm.
Yes, it is. And Tessa, do you see, let's plug in 12 itself. Is 12 greater than or equal to 12?
Yeah.
It is. So do you see how it's a solid dot? Okay. How about a multi-step inequality where we have a fraction? Now, what's the first thing that comes to mind when you see a number outside of parentheses where there's addition? The first thing that comes to mind? Distributive. But there are other ways you could do this. There is another really nice way you could do this. Hannah?
You could multiply both sides by
Right. Very good. So I'm going to rewrite it so there's a little room down here, since that's so close to the word solve. So right now we could distribute. If you do, you'll have a fraction next to the x, won't you? Or you could start off right now by multiplying by the reciprocal of the fraction, since it is the factor here. Multiply both sides by -3/1, which is just -3 really, isn't it? We're multiplying both sides by a negative, so what do we do right now? Switch a sign. Go do it before you forget. There's so much going on here that we can't neglect that, right? This just equals 1, and we now have x plus 21 is greater than what? 2 times that is -6. Good. And look how simple this now is. Right? So how do we undo, Ray? How do you solve for x? Good. From both sides. Does that cause us to change our sign? Subtract from 21? No. Ray, what causes us to change our sign? Dividing by a negative on both sides, or what's the inverse of division? Multiplication. So multiplying both sides by a negative, or dividing both sides by a negative. But subtracting a number does not change your sign. So what is negative 6 minus 21? Negative 27, good. Okay? So this, using the reciprocal to simplify is a really nice way to simplify a fraction. Well, that's not what that says, so I'm going to cover that. Could you distribute that fraction? Yes, you could. And you would still find that x is greater than negative 27. You would deal with that later. You certainly could distribute and find the same results, right? If you don't think of multiplying by the reciprocal at the very beginning. Okay, there are always more than one way to, there is always more than one way to solve these. Okay, so pause the video and then you can look at what we found here. And you may pause the video and check this nice work out if you need to. Very good work here. Okay, this is a little issue that we need to think about. Identifying the number of solutions of an inequality. A little bit of a tricky section you might want to highlight, actually. If an inequality is true, then, there are how many solutions to it? If an inequality is false, then there are how many solutions to it? How can we have a false inequality? This is strange. Anyway, if an inequality is true, then how many solutions have we noticed there are when we graph? What does the graph look like? Wesley? Good, he's saying infinite or unlimited. Because the graph looks like a what? It looks not quite like a line because there's a starting point, right?
Ray.
A ray. And rays are infinite by definition. They start at a point and they go on forever. Isn't that right, Ray? Are you infinite by definition? And so what might be true then if an inequality is false? What do you think? Do you think that there are infinite solutions if it's a false inequality? There are finite, you're thinking, or Jeremy?
Well, actually, it's like when you have
I don't know if this example is an infinite or a false statement. So let's just try it and see. Maybe it's the false one. And if it is, let's see how many solutions it has. So what would you do first in solving for x here? Mary?
you would subtract 3, or use 2.
Okay, so she's distributing. She says distribute this. So we end up with,
8x plus 2.
and over here we have 8x plus 3. And so there we go. So now we need to collect the variables to one side. Yes, so what would you do?
Subtract 8x.
From both sides, subtract 8x, and that didn't change our sign. We end up with 3 is greater than 2, which is very awkward and different. There's no variable here. So is this a true statement? 3 is greater than 2?
Yeah.
So then there would be infinite solutions to the original up here. Okay? Or if we take a look at this line here, where she simplified both sides, give me a number, any number at all. I hear 5. So what is 8 times 5? 40 plus 3 is?
43.
And 40 plus 2 is?
42.
Is 43 greater than 42?
Yeah.
So we could put anything at all into this. And let's try negative. Let's just try negative 1 to make this easy.
Negative 8.
Plugging in negative 1 here, we have negative 8. Negative 8 plus 3 is?
Negative 5.
Negative 5. And negative 8 plus 2 is?
You mean negative 1?
I'm looking over
Oh, no.
here at the right side.
Negative 8 plus 2 is negative 6.
Negative 6. Is this still true? Is negative 5 greater than negative 6?
Yes.
So see, a negative makes the statement true, a positive makes the statement true, 0 makes the statement true, anything makes the statement true. Infinite solutions, not just array. This is cool. There is a line, right? Infinite solutions possible here. Okay, any number at all. Okay, so that was that one. So we must have a more interesting one, which would be the false inequality, right? Let's see what this says. And so, Anthony, simplify this for us.
So distribute the 3. So So you get 24b minus 1
Minus 3 times,
minus 3
minus 3 is,
is less than or equal to 24b minus 4.
okay? And so now when we collect the variables all to one side, how would we do that?
Subtract 24b.
And that does not change our inequality sign, does it? And we have negative 3 is less than or equal to negative 4. Is this true?
No.
False. So let's go back up to this line again. If we plug in 0, we get right back to this bottom line, right? Negative 3 is less than negative 4. It's not true. Let's plug in just one positive number. What is 24 minus 3? 21. And what is 24 minus 4? 20. And is the statement true when we plug in 1? You see the statement is false. And how about plugging in a negative 1? If negative 1 times 24 is? Negative 24 minus 3 is? Negative 27, right? Negative 24 minus 4 is? Negative 28. And is this true here? Is there anything we can plug in to make this true? Are there any solutions at all to this? No, no solution. Okay? So if you have a false statement, when you simplify your inequality, if you have a statement like this that's false, then you say there are no solutions to this. Now, does that seem pretty simple? Is it going to be simple on a test?
No.
This is a type of thing that really haunts people on tests. They get to this point of 3 is greater than 2 and say, Mrs. Smith, my X's are gone. They seriously are like, I don't know what to do. My X's are gone during the test. And I have to say, well, we talked about that in class. And this time I'm going to say, and I asked you to highlight it. So maybe you should look at your notes before a test, because this will be on a test. Okay? And then the other thing people do is go crazy on a test thinking that everything has no solution. So watch out for that too. There literally are people who sometimes go, no solution, no solution, no. Yeah. I'm like, oh my goodness, they didn't even solve this thing. Of course. Do you think I'm going to put 15 no solution problems on the test?
No.
Probably not. Probably just a 1 or maybe 2, or maybe I could put 15 and then really mess with you there. Okay. I don't know. Okay, solve if possible, and then state how many solutions are there. Okay, so number 4, we see that we have infinite solutions because we have array, right? Array that goes to the left. And number 5 is an untrue statement, so there is no number that will be a solution in that inequality. And number 6, this is infinite solutions, but doesn't it feel like a bigger group of infinite than number 4? Because this one, any number at all, any real number may be a solution. That one, number 4, is limited to 4 and those numbers that are less than 4. So doesn't it feel like a bigger set?
Yeah.
Could this set of infinite numbers be bigger than this set? I mean, infinite is infinite, isn't it? Isn't that weird? But this set down here feels bigger, doesn't it? Okay, I want to add one problem that sometimes creates problems when people are starting their assignment. And it's write and solve an inequality to find the values for x. Okay, so let's look at this. This may show up on your homework, but it's a good thing to have in your notes. Okay? We're just going to do 34, so you have a little jump start on it. They actually give you a little inequality. It's given. It says area is greater than 81 square feet. Area is greater than 81 if you don't want to include all the units. There it is, a simple little inequality. But we need to find possible values for x. I don't even see x in my inequality. So we have to take a look at this figure and say, how do we substitute the x's in, right? How do you find the area of a rectangle or a square? This looks like a rectangle. Well, it looks like a square when I'm looking at the board, but when I look at my computer, it's more longer this way. But I don't know what it is. It could be either, right? How do you find the area of that figure?
A equals b times
You
a.
saw it already, right? Base times height. So let's substitute that for a. area equals base times height here, right? Okay, so this is good, this is organized. Now let's go find the base and the height. And the base here is either one, right? So let's say, Abby, what do you say? What's the base? Okay, so we put x plus 2, and the height then is 9. And so we just simply are substituting here. Okay? Now, do we have enough values in here that we could find and solve x? Yes. What will you do right now, Mary? Okay. So you have
9x.
plus 18 is still greater than 81. And now we're at a two-step problem, do you see? And you can solve. All you're asked is to find x, and yet you now are ready to do it. Okay? So this is a organized format for answering this sort of question. And the same, organization will work for 35 as well. Did anybody find it? Tatum? Tatum, what'd you get? Was it 72? So x is greater than, or is it 63? What is a got? 63. So she says x is greater than, when she divides it out, 7. So there you go. It could be anything greater than 7, which is true. Okay?